Let's try and solve this logarithmic equation. So we have log base 4 of 64 is equal to x. Okay. So in order to solve this equation, actually before I solve this equation, pause the video if you want to have a go at this one. But before we solve this equation, we have to simplify this side here, because technically the equation is solved. X is equal to this. However, they probably want us to simplify this into a regular number. So what we've got to think of straight away is, how can we represent 64 as a base of 4? So 64 could be 4 to the power of something, but let's say we don't know what that something is, okay? What we can do is we can trial and error a couple numbers, okay? So we could go, alright, 4 squared, that's 16. 4 cubed is 16 times by 4. That seems about close to 64 as an absolute guess, but what we can do is actually double check that. So 16 times by 4. 4 times by 6 is 24, so you write 2, 4, and then 4 times by 1 is 4. So you add those together, so what you get is 4 and 6, so you get 64. So here we can represent 4 to the power of 3 as 64. So if we chuck that into our logarithmic equation pretty much, what we're going to have is log base 4 of 4 to the power of 3 is equal to x. Now using the log laws we learned in the last video, we know we can take this power outside. So we can rewrite this as 3 log base 4 of 4. And we also know log of a number of that same number is just equal to 1. So this is just equal to 1. So we have 3 times by 1 is equal to x. So x is equal to 3. And that's it solved. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it. But let's take a look at the next one. So let's try and solve this logarithmic equation right here. Okay. Log base 2 of 3x plus 3 is equal to log base 2 of x minus 2. Okay. So if you want to have a go at this one, feel free to pause the video and have a go, but I'm going to get solving it right now. So what we want to do is we want to combine the logs, okay, into a single logarithm. Okay. So first of all, I can see they're all the same base of 2, and we have a random number in here pretty much. Ignore the number, just try and combine the logs. So I'm basically just going to swap, or actually probably move this one to the other side would be the easiest, okay? That way this doesn't become negative and you don't have all the stuff on one side. So what we want to do is we want to minus log 2 of 3x off both sides of the equation, okay? So if we did, that's a 2, that cancels out. So on the left hand side you have 3, and on the right hand side you have log base 2 of x minus 2 minus log base 2 of 3x, okay? Now using our log laws, we know if we're minusing 2 logs, you can write it as a single log, but you have to divide by whatever's in the brackets here. So everything the orange here can be written as log of 2, and then it'll be this divided by this, okay? Now that we've got to this step here, we need to rewrite it as an exponential because we can't do anything with the x because it's inside the log. So if you remember the very first log law, if you have a to the power of q and it's equal to b, that can be rewritten as log a of b equals q, except we're doing the opposite way in this case here, okay? So what we can see from our example compared to the rule is obviously our a is 2. We can also see straight away that our b is here, so that would go here, and that our q in this case here is the 3, okay? So we can rewrite this as the following. 2 to the power of 3 is equal to x minus 2 on 3x, okay? 2 to the power of 3 is 8, so we have 8 equals x minus 2 on 3x. Now the easiest thing to do straight away now is to move the 3x up there, okay? So a lot of people get stuck in like, oh, what do we do here? Just move the 3x up here and then we can just do a bit of algebra. So move the 3x up here. So we have 8 times by 3x equals x minus 2, okay? This gives you 24x, and this is equal to x minus 2. you're going to minus x off both sides to get all the x's on the left hand side. So if you go x minus x, this gives you 0. 24 minus x gives you 23. So 23x is equal to negative 2. Then you're going to divide both sides by 23. So you get the answer is x is equal to negative 2 on 23. Okay. Hopefully you got that. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it. But let's take a look at the next one. Okay. So let's try and solve for x. Log 2 of x squared is equal to 3 minus 2 log 2 of x. Okay, so let's have a go at solving this one here. Okay, so obviously this one looks a bit trickier than the previous one. However, this one can be solved pretty easily with a substitution, because notice this is exactly the same as this. So if we let's say a equal log 2 of x, if you substitute that in, you're going to get a squared equal 3 minus 2a. And behold, we have a quadratic. Move all this stuff to the left hand side. So you're going to get a squared plus 2a minus 3. Okay? Now it's just a case of, alright, what two numbers times together give negative 3 but add to give positive 2? Well, I can think of positive 3 and negative 1. So we have a minus 1 and a plus 3. Okay? Now since that's equal to 0, this means a minus 1 is equal to 0, or a plus 3 is equal to 0. Now since, remember, a is equal to log base 2 of x, we have to now put this fella back into the equation. So this goes into here and here. So you're given two different types of equations. So you have log 2 of x minus 1 equals 0, and you have log base 2 of x plus 3 equaling 0. Move the 1 to the other side, so we have log 2 of x equaling positive 1. And then we're just going to repeat this first law here pretty much. So if I just take this guy down, copy, we're just going to repeat this law for both of the examples. Okay, so using this law here, we can rewrite this as 2 to the power of 1 is equal to x. And this one here will have log 2 of x equaling negative 3. Now if we rewrite this, we'll have 2 to the power of negative 3 is equal to x. So that can be simplified as 1 over 2 to the 3 equaling x. So that would be 1 over 8 is equal to x. Okay, and that's that one solved. So it looked quite hard at the start, but with a substitution it made it very, very easy. Okay, let's take a look at the last one for this video, and then we'll probably do a part 2. So log base 2 of x, 2x, sorry, plus log base 2 of x plus 2 equals log base 2 of 6. Right, so let's try and solve this one for x. So first of all, combine the logs on the left hand side. Okay, so since you're adding the two logs, you want to write them as log base 2 but multiply what's on the inside here. Okay, so this would be log 2 of 2x multiplied by x plus 2 equaling log 2 of 6. What we want to do is distribute this straight away, so we can write that as log 2 of 2x squared plus 4x equals log 2 of 6. Now, here's a trick we can do straight away. If you get to this position here, if you have nothing else here and nothing else here, and you have log of the same base of something and log of that same base of something, in other words, you have this the same and you have this the same, isn't it logical to make the assumption that this is equal to this? Because if you're logging both, if you're basically, if we think of it like this, if we have 2x equals 6, and then you log both sides of that equation, that still means these are still equivalent. So shouldn't the same conclusion be made if you're going backwards? So what we can effectively do, now don't divide the logs. You can't divide a log, it's an operation. You can get rid of the log. So just make the assumption that these two are the same thing. So we go 2x squared plus 4x equals 6. Don't divide the logs. I will be a bit annoyed because that's not how you actually do them. It's an operation, not a times. This is logging something. This isn't log 2 of times something. It's an operation. Move the 6 across, so now we can see we have a quadratic here, okay? So minus 6 equals 0. Now what we can do is divide everything by 2 because they're all divisible by 2. So we would have x squared plus 2x minus 3 equals 0. And I think this is actually the same quadratic we got up here. So it's the exact same answers. So two numbers that times to give -3 but add to give 2. Well, that's x plus 3 and x minus 1 equaling 0. So your correct answers are, actually, x equals -3 or x equals +1, okay? Now, because in this example, x is less than 0, this is not a valid solution because you can't log a negative number. So this is the only correct solution, okay? Only correct solution, okay? Alrighty. I will see you in the next video solving log equations. If you enjoyed, please subscribe for more.